So today we're talking about the ambiguous case. Ambi means, I think, both, two. In this case, it's two, meaning, sorry, keep going. So ambi, for our purposes, means both or two, which means so far in trigonometry, there has always been one answer. Today, folks, we're going to do examples where there are two answers, where there are two possible answers. It feels backwards. It feels like it shouldn't be like that, but it is. Okay? So, what we need to do today is discern when there may be an ambiguous case in the question. So, the first thing we're going to learn is how do you check if this is an ambiguous case where there are two possible answers? Okay, not all triangles have two possible answers. So first we have to figure out what kind of triangle is it. Is it a one answer triangle or a two answer triangle? The next goal is explain the conditions under which an ambiguous case arises. So we're going to have a checklist and we need to understand those conditions so that we could be like, yes, ambiguous case, no ambiguous case. Step 3, once we know we have an ambiguous case, it is to determine the two possible answers. Okay? So let's talk about this. Well, while it might be obvious, a triangle can only be formed if the sides are the correct length to connect each other to a point. So yesterday, we talked about an example where if the two sides were 9 and 10 long, and if the longest side was 19, we talked about the fact that this would actually not make a triangle. It would be just a flat line, right? So there are certain conditions in which a triangle can exist. If this angle is the greatest angle and this length is 7, this triangle cannot exist, right? What that would mean is that this line would only go so far, right? The triangle would not be complete. All lines would not touch. So let's do a bit of and here's another example, right? Where we have two lines and this third line is kind of hanging there. It's not long enough to connect. So let's figure out what are those lengths that we need in order for a triangle to exist. In this section, we'll examine a case when given certain measurements, okay, we're going to have two examples, two possible triangles. So, and then the only time we can have this ambiguous case is when we have an SSA situation, meaning you're given a side, another side, and an angle. So the angle is not between the two sides. That's what SSA means. Let's make that note. SSA means angle is not between two given sides, right? When we talk about given, we're like, we know their lengths. So if we have an SSA, that is the first criteria to check for a possible ambiguous case. Okay, so first thing we're going to do is we're going to look at a situation in which we are given sides A, C, and an acute angle A. So that means it's less than 90. Note, this is the SSA, right? Side, side, angle. Why shouldn't I read it the other way around? It's not really SSA. Should I go left to right? No one? No one? Miles sees it. Oh, okay. Marley's like, obviously. Should I point out the obvious? You got it? Yes, please. Really? So instead of reading it SSA, what if I read it this way? That would just be not nice. You got it. You got there? Yeah. Good. But I could that would all right. So let's look at these cases where we have an acute angle A. In the first situation, what we have is that this angle, the A, is long enough so that it creates a right angle at C. In this case, how many possible triangles do we have? One, right? This is the obvious one. This is the one we've always been working with. Well, there's one triangle, okay? Now, what are the conditions? Okay, I know this is a bit confusing. The conditions are as such, and what we're looking at is what is the length of A. In each of these questions, in each of these examples, we're looking at the length of the side that is not touching the angle. A is not touching the angle, or we could say it's opposite from the given angle. So in order for this length to be perfectly the same length so that it creates a 90-degree angle, well, that would mean, let's do some work on the side. Oh my gosh, I'm a bit confused. That would mean this would be opposite, this would be hypotenuse. So I would have sine A is opposite over hypotenuse. And so to find A, it would mean it would have to be C times sine A. This is how I find. Hi, good morning. Hi. For which? Okay, I can probably pull it. Sebastian, your guidance counselor, wants to see you for like a couple minutes. Okay, go quick. Okay, so guys, so my first criteria that I figured out for is it possibly an ambiguous case is it's an SSA. Now we figured out, well, if the length of A is exactly equal to this side times sine A, that would mean, is this ambiguous or not ambiguous? Ambiguous means there's possibly two options. So is this triangle ambiguous? No. There is only one possible case for this triangle. Okay, so if this happens, that means it's not ambiguous. Okay, so that's one of our criteria. So let's write that down. So if this is true, that means triangle is not ambiguous, right? It means there is only one option for the answer. Yeah. Yeah. Let's get through it. And because I appreciate that you and I think many others are like, what is happening? I think we need to push through, get to the list of criteria, and maybe see an ambiguous triangle and kind of be like, oh, that's what she's talking about. All right, let's look at another triangle. So in this case, we've got a length of A, right? This is my A, that is too short to connect to B. In this case, how many triangles are formed? Null. Yes. Zero. Okay. So this is not an ambiguous case. This is just a case where there are no triangles formed. So in this case, if this is how you find, if this means that the line is just long enough to connect, what should I write here about A? Yeah, less than. So what we're saying is, oh, it's just too short to connect to the triangle. So instead of saying equals, I'm going to change it to less than. So A is shorter than the minimum requirement to connect and make a triangle. Okay, this version of A is shortest possible. That's the shortest possible value of A to actually make a triangle. Okay, then we have a case here where side A is, what can you tell me about side A compared to side C? No, actually, side A is longer. Okay, so when side A is much longer than C, how many triangles are we making? Two. No, one. It's like I know it's confusing. We're just making one triangle. Okay, because you haven't seen yet what I mean by two triangles. So in this case, again, we're making one triangle, and this means that A is greater than C. So we're going to get to the middle ground. All of these situations, these three situations, are non-ambiguous. Two of them give one triangle, one of them gives zero triangles. So what is left over? What have we not talked about yet? So now we're going to consider when A is greater than C sign. Right here we talked about less than. Well, what if it's bigger than this minimum? But A is smaller than C. Right here we're talking about A is bigger than C. Well, what if we're between these two criteria? So it's longer than making a 90-degree angle, right? Like, so the shortest possible length to make a triangle would be this length. But what if it's a bit longer? Do you see how this slanted A is a bit longer than the vertical one? Can you see? Folks, watch here. Can you see that this slanted A is longer than this A? Yeah. Okay, so what if it's a little bit longer? It's still going to make a triangle, right? And what if it is not longer than C? That's the tricky one. Let me explain. Okay, I need a stick for something. Oh, how convenient. All right. So, watch here. Folks, watch here. It's confusing. We're getting there. Stay with me. Take your phone, put it away. Are you on your phone? Okay. No, I wasn't looking at you. I was looking behind you. All right. So is this shorter than C? Yes, it is. Okay. I've made one triangle. Can I make a second triangle? Watch this. Do, 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 do. What if I put my line right here? So here, this length A is the same length as this length E. Now B can be as long as it needs to be. Because we don't know how long B is. That's an unknown. So B can be short or it could be long. But we do know A. So if A is longer than the vertical, but still shorter than C, we can make one triangle Or if we keep swinging the highlighter and having it connect a second time to this horizontal line, we make a second one. Okay. Now, if I'm like, well, can't I just make an infinite number of triangles? Well, no, because if I put this A here, do you see how it's too long to connect to that horizontal B? So the only two places where it connects is here. Then it's too long, too long, too long, too long, too long, and here. Should I do that again? Yeah.
Which one is which? Like, is the first one, is it A is like bigger than?
Oh, good question.
Which can I? Because I just want to write.
Yeah. So in both of these cases, A is the same length. In both of these, what we're saying is, if you have a certain length of that line that is not touching the angle, you can make two triangles with it. So in this case, there's two things we know. We know that A is shorter than C, and we know that A is greater than C sine A. These are two criteria to satisfy the ambiguous case. So if these two things are true, it means, oh, we've got an ambiguous case, meaning we've got two triangles that can be formed. One of those triangles is an obtuse triangle. Agreed? An obtuse angle. And the other one is going to be an acute triangle. Now, the one thing I want to talk to you about is, why does it have to be shorter than C? It's kind of gross, but I'm going to use it. All right. So let's say I have side A that is longer than C, right? So this would be longer than C. And think of this B as going on forever, because it can, oops. This B can be as long as it needs to be. So as I take my really long A and I start swinging it, the question is, when does it connect to the horizontal line? Too long, too long, too long, too long, too long, too long, over here. Can I make two triangles with this really long arm? No, I can't. So that's the reason why I can't, that's the reason why A has to be, this one has to be shorter than this arm. Okay? So what are our conditions for ambiguous case? First thing, we need the triangle to be SSA, meaning an angle is not contained. This means non-contained angle. So that's the first check mark. The second check mark is, oh, A has to be less than C. Now remember, C is the side touching the angle. Is this better? Is that better? Okay. And then the third one is, oh, we have to make sure that A is longer than the right angle triangle side. So A has to be greater than C times sine of angle A. You can also think of C as the adjacent side. Wait, so if we have this A, so C is the adjacent side, A is the opposite side. Yeah.
I thought that side was on the top.
Yeah. Uh, you're right. But this is not a right angle triangle. Okay, so maybe that could be confusing. From the two sides that are given, C is the one that is touching the angle. Maybe it's better to just leave it. Is it better to leave it as C is the side touching the angle? Yeah. All right, let me erase this. Use it if you want, but I think I just introduced something confusing. Yeah, what's up?
I have two questions.
All right.
For like the chalk eraser example,
Yeah.
is it not fine to have one triangle?
It's fine to have one triangle. All I'm saying is you need to know when you have to solve a question and find two triangles. Sorry, two angles, right? So, like, if there's an ambiguous case, it means there's more work to be done. And you need to know when am I supposed to keep going and doing more work. So it's fine to have one. It's actually much better. It's easier. But we're going to start doing questions where there's going to be two possible answers.
Right, okay.
Yeah, Liam?
You could also be given C, right? Like instead of B. But
Yeah, I know.
it would just switch.
And as long as the angle is not contained. Yeah.
So as long as you're given the side A and then one of those two sides touching the angle, then you could be in this case.
The ambiguous case, I think of it this way. There's an angle that doesn't have to, that's not an SAS sandwich, right? Yeah. All right. So, in the past examples, this was when A was acute. Well, what happens when A is obtuse? Okay. So, if angle A is obtuse, this is still SAS. Okay. This is side A. So we're still doing an SSA situation. We've got this side, and this angle. Okay. So if A is less than C, as you can see in this question, okay, how many triangles do we have? Yeah. If this is an obtuse triangle, A has to be longer. What if A is equal to C? How many triangles do we have? Do you see that we are 0? Because if it's the exact same length, we just have a flat line. Okay. So what that means is we have 0 triangles formed if A is shorter than or equal to C. Again, A is the side that doesn't touch the angle. So if the side that is not touching the angle in an obtuse triangle, okay, is shorter or equal to, we have 0 triangles. Okay, well, what if A is going to be greater than C? Okay, can I form 2 triangles? Let's see. Let me get this. So if I have this length, okay, and I swing around, can I ever make 2 triangles? No.
Can you move the B line backwards?
I cannot move the B line backwards. Yeah, because this is the angle. If I move B here, I'm changing the angle. Yeah, good question. So in this case, how many triangles do I have? Only one. So folks, can I have an ambiguous case with an obtuse triangle? No. That goes back to our criteria for an ambiguous case. So how about a right triangle? Can we have an ambiguous case for a right triangle? No. So the triangle must be what type of triangle? It's super cute. You just reminded me that I have a whole deck of triangle jokes. I love them. We'll start the day with them. Okay, so we have 4 criteria thus far. Yes. Oh, thank you. Thank you, Greg. You're right. It's not about the acute triangle. It's about angle A. Oh my gosh. It's that angle A has to be less than 90 degrees. Oh my gosh. Thank you. You saved me there. So yeah, because Angle B could be greater than, right? Angle A could be greater than. Angle C. It's angle A has to be less than 90. Okay, we're good. So we got 4 criteria. All right, let's try this out. In the ambiguous case, 2 possible triangles can be formed with the exact same side of A. So let's look at these 2 triangles. Now, notice, because A is the same length, we don't give these 2 connection points 2 different letters. We call them C1 and C2. Doesn't matter which one's which. But we acknowledge that this is the ambiguous case by saying C1, C2. Don't go DE kind of thing. Okay, so if you look at triangle C1, B, C2, C1, B, C2, what type of triangle is it?
Isosceles.
It is isosceles because side B, C1 equals side B, C2. And what else is equal at that point? Angle B, C1, C2 is equal to angle, B, C2, C1, right? These 2 angles are identical because it's an isosceles triangle. Yep. Oh, we went ahead. Which 2 angles are the same? Okay, so we labeled it. Now, watch. Okay, here is the next step. What is the relationship with C1 and C2? So this is the angle of C1. And this is C2. So let's first, thank you. Let's first go and just analyze this little bit. Luke, stay with me. So if I just look at this bit, what can you tell me about these 2 angles? They add up to 180. Okay, so we know that they're going to add up to 180. So we're going to say, let's call this little angle, just to make our life easier, let's call it P. So we can say angle C1 plus P is going to be 180. Let's call this other little angle Q. Yeah, we can just call it C2, sure. Let's call it C2. So we know that angle P equals angle C2, right? Okay, so can I do some substitution? Right, let's sub this into this equation, and I get that 180 degrees equals angle C1 plus angle C2, which makes them supplementary angles. Do you remember that word? Let's write that down. Supplementary angles. So those 2 triangles that are formed as a result of the ambiguous case, they're actually quite related and they are predictable. Those 2 angles that are formed are supplementary angles. Okay, let's do an example. Okay, solve triangle ABC. If angle A is this, AB is that, okay? Round the side length, blah, blah. What do I do first? I draw a picture. Folks, it doesn't matter. I actually try, like on the test, you're going to get an equilateral triangle that is actually not equilateral, meaning I'm not going to draw it to scale. This is angle A, this is angle B, this is angle C. So don't worry what kind of triangle you're drawing. Angle A, I'm told, is 44.3 degrees. Side A is 11.5 meters. and side B, actually, let's switch my B and C for your sake. Make this C, make this B. Side B is 7.7 meters. Okay, other way would have worked too. It's just a little more visual this way. And then they're telling us to solve the triangle. Okay, well, before we can solve the triangle, I'm right away noticing that the angle is non-contained. So I need to do an ambiguous case check. Okay, so let's do an ambiguous case check. So the first criteria is it SSA? Yes, it is. This is an SSA triangle. We might have an ambiguous case in our hands, folks. The second criteria we have, if we look back at our list, is that A has to be less than C. A has to be less than C. Is that satisfied? No. As a result, yeah. What does that mean? Do we have the ambiguous case? Thank goodness we don't. But let's just go with it and let's just do the other two checks. The next check is A greater than C sine of A? Now, because I've already failed one, I know this is not ambiguous, but we're just going to do it. And then the last one is A less than 90 degrees. So A less than 90, yeah, that is. Let's see what we get here. Is 11.5 greater than 7.7 times sine of 44.3 degrees? Yes?
If B is 7.7, how do you know C is, how do you know A is bigger than C if you don't have C?
Oh, take that back. No. In this case, sorry, because we have B, we have to change our criteria. Thank you. Man, you're helping me out. We have to change our criteria today. Right? So B is the other side. So instead of talking about C, we're talking about B. Now, for some people, this is going to be really tricky. So what you might want to do is relabel your triangle so that the C is the side that's in the middle. Right? That's another option. And when we do this, we get that 11.5 is greater than 5.4. So we got a check mark there. But 3 out of 4 is not good enough. We need 4 out of 4. As a result, is this triangle ambiguous? So how many possible triangles will be formed under these conditions? One triangle. So we will say this triangle is not ambiguous. And there is one possible triangle. Yes.
When did you decide to check if it's ambiguous?
Yeah. As soon as I saw, so the question was, why did I choose to check if it's the ambiguous case? And the reason was because I saw that this triangle is an SSA, side, side, angle. Okay. So because it's ambiguous, I have to check. Now, folks, we're not going to go through and solve this triangle because that's old news. We know how to do that. We know we're going to get one answer. What are we going to solve for? Well, we're going to find this side, this angle, this side, right? Yes. Go ahead. Yeah. How much more do I have of today's lesson? So you know what I'm going to do? I am going to do this question tomorrow after the quiz. All right. Let me give you your. So, folks, you might. Let's see which home.